Okay, so the situation we've got here is we've got a contractor, and he is building a planned subdivision, and he has 3 different models of houses that he builds. Models A, B, and C, probably different in the square footage or the size of the bedrooms, or how many bedrooms or something like that. And it has a choice of 2 styles, a Spanish style and a contemporary style. And the matrix P here shows you how many of each style of house that he has planned. And it shows that he's not making any of the model A in the Spanish, it's only in contemporary. And then he's making 10 Spanish and 20 contemporary of model B, and 20 Spanish and 20 contemporary of model C. And then the amounts for the exterior materials depend primarily on the style of the house. So his materials are concrete, lumber, brick, and shingles. And concrete only costs 20. We'll probably have, let's see. It doesn't give us an actual unit for that, but I don't think it's $20. So the cost per unit of the concrete is 20 for lumber, 180 for brick, 60, and for shingles is 25. And then when he's considering these costs, he needs to consider for each style of house, this is his cost for the unit, but this is how many he actually needs for each style of house. So for the Spanish house, he needs 10 units of concrete, 2 of lumber, no brick, and 2 units of shingles. He also needs 2 units of shingles for the contemporary, but 20 units of brick, 1 unit of lumber, and 50 units of concrete. So what they want to know is what is the total cost for these materials for each model. What would we do to find that using the matrices? Which 2 matrices do we need to multiply?
The one with the model A, B, and C, and then the cost per unit.
Okay. So let's kind of talk through this to make sure we know what we're doing. Looking at the 30 contemporary Model A's, how many units of concrete, lumber, brick, and shingles, I'm sorry, how many of those do they need for that model?
For model A,
Mm-hmm.
I want
Model
to
A
say-
contemporary.
I would say you have to do the 30 times the 51, 20, and 2. But I don't know.
Okay, that sounds reasonable. And then would you do the same thing then for your 20 of Model B? Okay. So it looks like we're going to need to do a multiplication.
So, you can't multiply the matrices for the model A, B, and C and the cost per unit because they don't match, like they're outside, the matrices don't equal the same number. But you can multiply the model A, B, and C versus those one.
Okay,
Because that's a 3 by 2, and there's a 2 by 4, and then a 4 by 1.
okay, can we multiply a 3 by 2 times a 2 by 4?
Yes.
Because our inside dimensions match, right? Okay,
And then you can do 4 by 2 by 4 by 4 by 1, and matrices match.
right. So knowing your dimensions, remember we talked about that last time, knowing your dimensions helps you figure out what you can and can't multiply. And since we're looking for cost, and we're looking for total cost, we need to know how much for each model, and then how much for every unit of the materials. So we would take matrix P which is the planned number of models, times matrix Q, which is the number of units that each one has. And that'll give us how much of each material. Okay? So for part A, we're going to multiply the plan matrix, the number of houses matrix of each model and each style, and we're going to multiply that by the cost per unit of material, which is, I said it backwards. We're going to have to multiply it times Q because we need to know how much of each one we need. Okay, now this is only part of the solution. We have to get started first. And what I want you to think about here, let me switch over. We're going to have to figure out how many, because we need to know how many units, and then we know how much each unit costs. So our preliminary multiplication is to take P, which is the number planned, it might have went too far, times Q, which is the amount needed and matrix P times matrix Q, with P being a 3 by 2 and Q being a 2 by 4. Those have to match. And matching them does make sense because that tells us when we multiply the rows of P times the columns of Q, we have in concrete, no concrete needed for a Spanish Model A. But 30 times 50 or 1,500 needed for a contemporary. Okay? So that multiplication makes sense. And then the same thing, we've got 10 Model B that needs to go by the same thing, same price for each one of these. So when we actually get done, we'll have a 3 by 4 matrix.
So when that matrix comes out, the rows they're labeled more so like A, B, C, like here off the side. And then
Right.
the bottoms would be the materials, correct?
Right. And that's what I wanted you to see, is that your rows match the columns, but the rows are model A, B, and C. And when you get finished, your columns in your resulting matrix are materials, which is, we'll call it concrete, lumber, brick, and shingles. Okay? That way we'll be able to read across a row and tell that for Model A, this is how much concrete, this is how much lumber, this is how much brick, this is how much shingles. The hardest part about the applications problems is not doing the math. Calculator's going to do the math. You have to figure out which matrices you need to multiply and what order you need to multiply them in. So that's why I didn't want to get into this yesterday. We only had a couple of minutes, we need a little longer than that to talk about it. So when we actually do that multiplication, go to the calculator I'm gonna clear it off from last time. Hit matrix, go to the edit button, and our number planned matrix is a 3x2. So 0, 30, 10, 20, and 20, 20. And then we'll use matrix B for Q, and Q is 2x4. And we have 10, 2, 0, 2. And 51, 20, and 2. And while I'm here, I'm going to go ahead and enter the other matrix because we know that we're going to need to use it. And so it's going to be a 4x1. So now from the home screen, we're going to multiply the 3x2 times the 2x4. And this is the matrix that we get. Oops.
Your last column is different.
Okay, let me go back and check my math, or my entries.
I'll check the one. Yeah.
You print out matrix.
How do you make it?
Yeah, I'm thinking that's the one because this one's right, so matrix 2.
Oh, you put it 3.
Ah, yes, I see that now. Let's go back and fix B. Okay, so 30, 40, 60. Yeah, the first 3 should have been right. It should only be the last one. And this is the ABC. And then this is your different materials. Now this is your amount matrix. That's the total amount of the materials that he needs, okay? That doesn't answer the question that we were asked. But we have to have that matrix to answer that question. So now that we have the total amount, now we need to multiply by price. So we're going to take that matrix, which is, your calculator thinks that's answer, and we're going to put a multiplication symbol. Can I multiply this matrix times matrix R? Okay. So that gives us the total cost. Okay? Could I instead have multiplied matrix R times this matrix? I mean, it seems like that's the same thing, so can I do it in the other order? Why not, Kim?
Because they don't match.
Their dimensions don't match, that's right. Because this is a 3 by 4, and this is a 4 by 1. And because these match, my answer should be a 3 by 1, which makes sense because I'm getting the total cost for each model of the house. But if I tried to do it the other way around, even though it might seem logical that I should, I mean, you know, it's total amount of materials times the total cost. If I try to do it the other way around, my inner dimensions don't match. Okay? Question?
What did you put in C?
Matrix C is what is R on your paper.
Okay.
So in the long run, our final matrix answer, this is our total cost matrix, is $72,900, and that's for model A. $54,700 for model B, and $60,800 for model C. Now, this is the matrix, but I need to answer the question. So the answer to part A is actually Model A will cost $72,900, Model B will cost $54,700, Model C will cost $60,800 for materials. Okay? That's just for the building materials. Now, this is not part of that question, but what else might they have asked you about that you would have had to done a similar multiplication? What do you have besides materials and building a house, as far as costs? Labor, okay? So you might have to do a similar process for labor. But the only thing that would be different would be that the matrix for labor would be laid out like the matrix for your materials, and you do the same order of multiplication, which is why matrices make it very efficient. Okay, our second question, how much of each of the 4 kinds of material must be ordered?
Don't we already answer that, basically?
That's right, we already answered that. Where's our answer?
It's the key, P-trans.
That's right. Well, this is the amount matrix. So this matrix answers that question.
Each one, I'm picking a few.
Let me scoot it up some more.
Okay.
Okay? So one of our steps along the way tells us how much we needed. But now the question is, and we've got to answer the question, remember. We'll slide that up where we can still see it.
You're gonna add up each column.
You have to add up each column, right? So if I add up each column, and there is not a way for your calculator to do this, by the way. You can create a matrix out of it, but there's not a way to get it to add up your columns. For, let's see, concrete, we have 1,500, 1,600, 2,600, $3,600, $3,800.
I put, units.
Oh, yes, units, I'm sorry. And since concrete is in cubic yards, and 70 plus 60 is 130. Let me switch back over to the camera. 130, probably, stop that. In this case, lumber comes in board feet. And let's see, brick, I'm not sure what the units would be on that. Let's see what they say it is.
It says in thousand.
And yeah, 14. And yes, and if we go back and read the problem, that is right. This should be 130,000. Because if we go back up to the problem, says the lumber is in units of 1,000 board feet, the brick is in thousands of bricks, and the shingles is in units of 100 square feet. So when we're answering this last question, that's the way we answer it. And I think I've already got it in the PowerPoint, so I'll just go ahead and switch back to that. So 3,800 cubic yards of concrete, 130,000 board feet of lumber, 1,400,000 bricks, and 20,000 square feet of shingles. Okay? And you would want to answer that way. Actually, if you were doing this problem in Excel, you would have a way in Excel to come up with that T matrix because you could sum up your columns using Excel. So Excel is used quite a bit in this kind of problem. Question C is, what is the total cost for exterior materials?
Usually, I guess you do 2 times R, right?
Well, actually, you're going to use T times R because T tells you the total amount, and then your price matrix tells you how much each thing costs. So you're going to multiply matrix T, which was the 3,800, 130, 140, and 200, the row vector, times the column vector, which represents the individual cost for each material. Okay? And when you multiply those, since it's a row vector, 1 by 4 times a column vector, 4 by 1, you get one answer because it's a total cost. So the total cost for the exterior materials is $188,400. Okay?
How is that done if we don't use the calculator?
Excuse me?
How is that done if we don't use the calculator?
Let me switch over here. Let me write it down first, because if I don't write it down. Okay. So this is actually the matrix from this answer. This one here. This matrix was given to us on the first problem, when the problem was set up. Okay, that's your cost per unit matrix. So the way that they're actually arriving at this is they're multiplying 3,800 times 20 per unit. So that's the total cost for concrete. I'm trying to remember the order. And then 130 times 180 is $23,400. And then 1,400 times 60 per unit and I'm going to check that and make sure I did it right. Okay. And then the last one is 200 times 25. So we have that cost. So the actual total cost is going to be the sum of those numbers. And since we already have that total cost, I'll let you add those up. That's actually how the process was done. Okay? And thinking through the process actually helps you with figuring out how, you know, did you choose the right things? Okay? My brain's telling me there ought to be a way to get it to come up with that matrix T, but I'm not intuitively figuring out how to get the calculator to do that. Okay, the last question says, suppose the contractor builds the same number of homes in 5 subdivisions. Calculate the total amount of each exterior material for each model for all 5 subdivisions. Well, really, the only thing you need to do is to take that original matrix that we started with in this last problem, when we first multiplied part A and multiplied P times Q. We just need to scale the result of that by 5. And we could do that right now on the calculator and not have to redo anything hardly. Get that back up there. Because we still have that matrix in the calculator, we will say 5, matrix, A was P, and then matrix B was Q. So the calculator takes care of that for us too. Okay?
So is it times?
Excuse me?
5 times?
Yeah, 5 times the P times Q, which we used as A and B. Okay? Now, it seems like we've eaten up a lot of time doing this problem. You're thinking, okay, there's no way she's going to get done with 2.5. 2.5 is really fast because it is all, once again, calculator. We're going to talk about matrix inverses. We're going to talk about the inverse of matrix, which is comparable to a reciprocal. If you think about it, we have added matrices, we have subtracted matrices, we have multiplied matrices. What's the only arithmetic operation we've left out? Division. Can you divide matrices? Well, not exactly. Not exactly. But a comparable operation for division is taking the reciprocal of something. In other words, if you wanted to divide something by 3, you could multiply it by the reciprocal of 3, 1/3. Okay, well that's kind of what we're going to do with matrices. The real number 1 is what we call the multiplicative identity for all real numbers. So A times 1 is equal to 1 times A, and that's just A. So the idea of what a reciprocal does is a reciprocal of a number times the number itself gives you 1, which is the multiplicative identity. we're gonna call an identity matrix I, and it has properties that are similar to the number 1. And we can find the multiplicative, we can find the identity matrix as long as the matrix we start with is square and it has an inverse. And its inverse is kind of like its reciprocal. So a 2 by 2 matrix has the properties of an inverse matrix is 1, 0, 0, 1. And that means that for any matrix A, B, C, D, where A, B, C, and D are numbers, it must be true if we're talking about those being reciprocals, that A, B, C, D times 1, 0, 0, 1, or the identity matrix is the same as the identity matrix times the original matrix. And we're not going to worry about verifying it. Even though it says it's easily verified, we don't care. But we are going to verify that these two matrices are inverses of each other. And the way you verify that is you multiply matrix A times matrix B, and if you come out with an identity matrix, a matrix where there are 1s on the diagonal and 0s everywhere else, that's the identity matrix. And if you multiply two matrices and get the identity matrix, that means that the two matrices are inverses of one another. And in this one case, the multiplication is, it doesn't matter about the order, but only in this one case. Now we can do the verification on the calculator. Just put in matrix A and matrix B and multiply them together and see if you get the identity matrix. Now, knowing that there is such a thing is useless on its own. We can find out if any matrix has an inverse by putting it in the calculator and asking it for the inverse. And it'll either tell us what the inverse is, or it'll tell us that it's a singular matrix, which means it has no inverse. So if you were to put in matrix A as 2, -4, and 1, -2, and then try to do the inverse of that matrix, it's going to tell you no. It's going to say, quick, singular matrix. And your response on that one is matrix A has no inverse.
On the calculator, how do we do the negative one?
Look on your calculator right above the x squared key. That's a little it's like a little -1 exponent, except it really isn't. I mean, it behaves like one. If I put 3 to the -1, it comes back with the answer 1/3. But when you use it with matrices, it comes back with the inverse.
Okay.
Okay?
So,
Which one are we thinking?
Let me clear it off so everybody can see. Go to matrix, and we'll make matrix A into this 2 by 2. So it's 2, -4, 1, -2. Thank you. So matrix A and the little -1 button right here next to sine, cosine, tangent, and above the x squared, and hit enter, only it tells you singular matrix. This one doesn't have an inverse. Now if I go back, let me go back a couple of So we'll just quit. I'll go back to the matrix and edit matrix A and make it 1325. And it gives you the inverse of the matrix. So if it has one, it'll tell you what it is. If it doesn't have one, it'll tell you it doesn't have one. Okay? Not all square matrices have an inverse, but only square matrices have an inverse. Now, this is why, like I said, you know, that's nice, but who cares, because it doesn't really tell us anything useful. The useful part comes in because we can use the inverse of a matrix to solve a system of equations. Okay? And we're just going to do an example so you'll see how that works. So we're going to use the inverse of the coefficient matrix to solve this system of equations. Now, we could solve this system of equations by graphing it. We could solve it by using row operations, like we did in section 1. We can solve this equation using the reduced row echelon form, or REF on the calculator. But it's also sometimes, if you have several different equations to solve, where the solution will be repeated every time for a part of it, sometimes the matrix is a more efficient way to do it. So the way we're going to do this, we're going to go and edit matrix A. And it is 2, -3, 1, 5. And that is simply the coefficients of the variables. Okay? That's just the coefficients of the variables. We're not including the constants on the other side of the equal sign. So we're not doing the augmented matrix here. We're doing a coefficient matrix. B is the constant matrix. So we're going to quit from here and go back and edit matrix B, which is a 2 by 1. And matrix B is 4, 2. And now this is how we're going to solve this system of equations. We're going to multiply.
Did you put anything, did you just go back to edit matrix B?
Mm-hmm.
And what did you put in?
4, 2. You have to edit it back to the dimensions 2 by 1. Now, can you multiply 2 by 2 times the 2 by 1?
Yes,
Yes, because the 2's match and the outside is going to tell you the answers. And that's a good thing because our solution has to have a matrix that is 2 by 1. Okay? So this is how we're going to solve that problem. Excuse me? You don't. You don't. What we're going to do is we're going to multiply A times X is equal to B. Let me get to the next slide so you'll see how this works. Get the calculator back up here for a second, okay? What we're going to do is we're going to multiply that matrix A. We're going to take its inverse and then multiply it times B. Now, you don't actually have to take the inverse unless you just want to write it down, but we'll do it this time. Here's matrix A. We're asking for its inverse. Yes, it has one. Notice it came out in decimals. Ick. Don't want decimals. Don't want to have to write down all those digits. But I can go, before I hit enter, go to math and choose fraction, and it will give me the answers to matrix A inverse as fractions instead of decimals. Okay?
So on the test, would you want us to put those fractions down?
If I ask you to find the inverse of the matrix, I would probably tell you, give the answer as fractions, because I know your calculator will do it for you. Or if it is going to be decimals, and I know it's going to come out to be decimals that won't go into fractions, I'll tell you how much to round them.
Okay.
Okay? Now really, knowing what that matrix inverse is doesn't help me. What I want to do, I'm going to clear it off here. Matrix A inverse matrix B. The answer is 2, 0. X is 2 and Y is 0.
Okay.
So that's the matrix XY.
So we don't have to do the fraction part, we just need to
No.
go ahead and do.
Well, what I would want you to do is I would want you to do the fraction part so that you can show me your work.
I didn't see how you wrote that A fraction.
Okay, you just hit, you first got to get your matrix A,
Yeah, I already did.
and then your -1 is the x to the -1 key right above the x squared key. It is not the same thing if you put a power in a -1. It has to be that little -1 key because that's the inverse key. Are you getting it?
So,
And so you're clear what I would want to see on the paper. And I'm not just being persnickety here, there is a reason for this, because remember, not all matrices have an inverse. If you're going to solve it using the inverse, what you have to show me is that that. I want to see what you put in for matrix A, what you put in for matrix B, and then that you solved it using the matrix inverse. Because you could also have solved that problem and go down here to C.
So you don't have to do like the x, y, and like put as in 2x minus 3y, and then the x plus 5y.
So the actual XY is 2, 0.
Yeah. That's your solution matrix.
so if we substituted that 2 for the x's and the 0 for the y, then it would equal 4. and it would equal
Mm-hmm. So, this is the section 2 way to do this. You do the augmented matrix, and then you go back to matrix, over to math, and do reduced row echelon form of matrix C, and you read off that the solution is x equals 2 and y equals 0. Same solution. Solution didn't change. Just the method, two different methods to do it. Now, the thing is, this method always works. The inverse method won't work if the matrix you're starting with your coefficients doesn't have an inverse. Okay? And you're probably sitting there thinking, well, if that one doesn't always work, then why can't I just use the one I learned to begin with? So we're going to look at the application problem. Three brands of fertilizer available to provide nitrogen, phosphoric acid, and soluble potash to the soil. One bag of each brand provides the following units of each nutrient. Fertifund supplies 1 unit of nitrogen, 3 units of phosphoric acid, and 2 units of potash, whereas Big Grow supplies 2 units of nitrogen and 1 of phosphoric acid, but no potash. And Sokum provides 3 of nitrogen, 2 of phosphoric acid, and 1 of potash. For ideal growth, a Michigan farm needs 18 units of nitrogen, 23 units of phosphoric acid, and 13 units of potash per acre. The corresponding numbers for a California farm are 31, 24, and 11, and for a Kansas farm are 20, 19, and 15. How many brands for each state? How many of each bags of each brand for each state for their farm? So rather than solve 3 separate systems, what you want to do is you want to come up with this matrix, and these are the amounts of your nutrients. So it's always going to be, we're going to call Fertifund the X, Big Grow is the Y, and Sokum is the Z, because we're wanting to know how many units of each brand. And if you add up X plus 2Y plus 3Z, that's how many total units of nitrogen, which is A, that you can get for the brands. And if you add 3X plus Y plus 2Z, that's how many units of phosphoric acid you can get for a total B. And then 2X plus Z, because there is no potash in Big Grow, will give you the amount of potash that you can get. Okay? The thing is, though, those numbers A, B, and C are going to be different for each state. Okay? They're different for each state. So rather than have to enter a new augmented matrix for each state, this is where the matrix comes in. Yes?
Sorry, is the A, B, and C then the nitrogen, the phosphorus, and the sodium?
Yes. Yes, it represents the nutrients. So matrix A is the coefficient matrix. Matrix X tells you how much of each brand you want to buy. So if I do AX equals B, then B is going to give me the, when I do the inverse, then it's going to give me the answer that I need for one farm. The problem is, B is going to be different for each one of the farms, so I need to find the matrix inverse one time. Okay? So, looking on your paper, let's put in the matrices. Matrix A is 3 by 3 because we have 3 different brands, 3 different amounts. And it's 1, 2, 3, 3, 1, 2, 2, 0, 1. What did I do? Okay. And because I'm going to be using it so much, I want to go and actually check that matrix A does look like it's supposed to. And it does. And at this point, before I go trying to do all the other stuff, I also want to verify that matrix A actually has an inverse. So I'm going to go matrix A, x to the negative 1. And yes, it does have an inverse. And once again, you can change it into fractions to make it easier for you to write, really is the biggest reason to do it. So yes, it has an inverse. Write down what its inverse is. And now we need 3 more matrices. So let's see, we have Michigan, California, and Kansas. I don't think we have a matrix M. Nope. So we'll just use B for Michigan, C for California, and D for Kansas. So for Michigan, that's going to be a 3 by 1, and they need 18, 23, and 13. For the different nutrients, right? And then while I'm doing this, I'm going to just do all 3 of them since I know that that's how we're going to solve this. So for California, it's also a 3 by 1. And for California, they need 31 nitrogen, 24 phosphoric acid, and 11 potash. And then for Kansas, my problem says they need 20 nitrogen, 19 phosphoric acid, and 15 potash. And again, it wouldn't hurt to go ahead and check to make sure you entered those right. So matrix for Michigan looks like this. California looks like that. And Kansas looks like that. Make sure that matches the numbers in your description. Okay? So here's how we're going to solve it. We're going to go matrix A inverse times matrix B. So for Michigan, they need to get 5 bags of Fertifund, 2 bags of Big Grow, and 3 bags of Soakum. And at this point, you don't even have to re-enter matrix A inverse. You can just go second enter and change matrix B to matrix C to get your next answer. So for California, they need 12 bags of Fertifund, 4 bags of Big Grow, and 7 bags of Soapin, so they need different amounts. And then finally, for the Kansas farm, we get an answer that doesn't make sense. Because it says X is 1, Y is -10, and Z is 13, and you can't have a negative number of bags. Okay? So that means there is a solution for this, but the problem with getting this solution with -10 in it, basically the farmer's gonna have to purchase an excess of some of the nutrients to get what he actually needs. So he's gonna have to buy more of one particular kind of fertilizer than he needs and just not use it all, is what it comes down to. He's gonna have to buy more of the, which one is it? Big Grow than he needs. He's not gonna use what he buys. Okay? Now, we can't solve that problem in this chapter, and we're not going to do linear programming in in chapter 3, I think it is, the end of the chapter. We're not gonna get into problems that will solve that. We will find a way to do this at a minimum cost in the next chapter, but we're not gonna do something called the simplex method, which you'd have to solve that problem. Okay? Does anybody have any questions over what we've just covered?
When
Yes.
I plug it into my calculator, I'm not getting the 5, 2, and 3 for Michigan. But I don't know if it's because I plugged it wrong or not, but I like double checked it. I can't figure
Are you
it
getting the
out.
right answers on the others?
I haven't even checked.
Okay, double check both your matrices first. Double check both matrices.
And 1, 2, 3, 1, 2, 2, 0. None of the dots right.
That's the inverse. You don't need that, you don't actually have to do that. So, we'll check matrices.
I missed the last one, because I heard that negative
So
sign.
that's how it's
Okay. Yeah. Okay, now, going back and thinking just quickly here, what happened in section 1 when we did graphing and solving by graphing and solving by algebra? Is there always a solution? No. Sometimes there's infinitely many solutions, and sometimes there's no solution at all. So the question is going to come up here: what happens if you get an inconsistent system, one that has no solution? Okay, I'm gonna show you quickly how this, well, actually, I'm not gonna do it in the calculator, because we don't really need to do the calculator for you to see this. You know that the coefficient matrix here doesn't have an inverse. That means either the given system has no solution or an infinite number of solutions. So we would have to figure out which that is. And that means we would have to go back to the RREF method to figure that out. The other thing is you could figure it out algebraically, because if you look at this realistically, 2 times the second equation is the same as the first equation. So that's really only one equation, so you have infinitely many solutions. But everything that solves one solves the other.
I don't understand what you just said.
Okay, if you were going to try to solve this by the other method, what happens if you multiply 2 times x, 2 times -2y, and 2 times 2? What happens?
0.
If we were doing the difference, we would get zeros, okay? So that means that this is an inconsistent system. It will be 0 equals 0. That's true. I'm sorry, it is a consistent system. It does have solution. It has solutions, lots and lots of them. Anything that you plug in an X and you can figure out what Y will be to make that too. Okay? This one has no solutions because the left side is double the left side of the second equation, but the right side's not. If I multiply here, 2 times x and 2 times negative 2y and 2 times 1, I wind up with 0 equals 11. And that's not true either. Okay? So if a matrix doesn't have an inverse, you can always use the inverse matrix to solve a system, as long as it's a square matrix. And if it's a system of equations, it's going to be a square matrix. So you can always use the inverse as long as it's got one and get the solution. If the coefficient matrix doesn't have an inverse, it's either an inconsistent system or there's infinitely many solutions. Okay?
So on the test, do we need to identify which one it is?
If you do, what I would do on the test is I would go back and do the RREF solution to it, because that'll show you which of the two it is. Let me go back and show you how we'll do this. If we put in the augmented matrix, instead of trying to do it with the inverse, if the inverse fails, try the augmented matrix. Let's see, it's 2 by 3. We've got 2, negative 4, 13, 1, negative 2, 1, and second quit matrix, math, reduced row echelon form of matrix A. And our last row is 0 plus 0 equals 1, which is clearly not true, right?
Yeah, so I guess you go and try the A, negative 1, and B.
Yeah.
And
Try
then-
that first, because
If you
that
do
is the
that-
most efficient way to do it.
So if you don't get that, go back and change your matrix to include the whole equation
Right.
within that same matrix.
Right, and if you're putting your coefficient matrix in A, all you really have to do is modify the dimensions of A and make it have one more column, and then put in your constants.
Okay.
So if I move back to the one before this, come here, calculator, and go back and edit matrix A, and all I'm changing here is the last entries. This was 2 and 1. So 1 is still the same. And then I do reduce row echelon form of A. Now I get 0, 0, 0. 0 does equal 0. So that means there are solutions, not just one, but many solutions. Okay? Anybody have any questions, any thoughts? If you have questions before the test, send them to me on Remind. I will go in and extend, if I haven't already, I'll go in and extend the quiz due date until Monday night.
Will that be for
Go
chapter 1?
Chapter 1 and 2. I will extend the quizzes till Monday night. Okay?
And so our test is this Tuesday,
Mhm.
and you said that are you still gonna send this out?
I will send you out a study guide. The study guide that I send out, I'll also send the answers, but they'll be separate.
That's fine.
Okay? In fact, I probably will put the study guide in Shelby, since that's an easy place to keep up with it. Okay?
Can you print out Shelby?
You can't, but you can upload it to your Dropbox
Because when I
and
study.
then print it from a PC.
I like to
Probably do a screenshot of it to show you.
Yeah. I just like to have the paper version when I'm studying.
Okay, well, let me see if I can get this thing to mirror, and I'll show you how I do it. Do you have iCloud or Dropbox or anything like that? Any online storage?
On my iPad, I don't even know.
Okay. Well, you can email it to yourself too. When you're out there.
Okay,
Yeah, you can email it to yourself.
I'll do that then.
Do you know how to screenshot on your iPad? Do you know how to screenshot?
Yeah, I'm not.
When you do a screenshot though, you don't get as readable a document. Let me get into Shody and I'll try to show you. Let me-
There is no changes one to one, just check, so it's some comments. Like I said, a couple of them are some,
Are you okay with me?
Yeah,
okay.
Yeah.
Let's make next year.
yeah, just send me a reminder, but I already plan to come at, you said 11?
Yeah, I get, well, yeah, we get our after 11, so, you're in the faculty building, correct?
Second floor.
Maybe you could do my advising while we're there.
We probably could.
You're my advisor too.
I just don't understand.
Yeah, you can be my advisor, is that or take-
Can you like turn them?
Okay, you see this?
Yes.
You see the little icon right up here in the corner that has the paper pointing upward? You touch it,
I see. Oh, okay.
okay? Now, unless you've got a printer that works with your iPad,
I do.
okay, then you can print it from there.
Okay.
Or you can email it to yourself, and you also have the option of opening it with other applications if you wanted to.
Okay.
And for mine, I use my Dropbox. If you don't have an online storage, just download the Dropbox application.
Okay.
I can send you an invitation and you can,
I'll be great with that print, so
Okay.
that'll work perfect for me. Thank you.
you're welcome.
I'm not here in this next week.
Let's see. That could make it something, yeah, but I can't remember where it was on here. Okay, well, let's look at your matrices first. 2, 3, 3, 1, 2, 2, 0, 1. Okay. You're not getting it on any of them? Okay, matrix B, 18, 28, 13. That's right. Thirty-one, 24, 11. Okay.
I don't know if it's for everybody, but if you try to do my math guide on the iPad, it won't let you do matrices. Or do it online.
I have to go in and look, because I haven't tried that on the iPad yet.
I was about to throw something last night.
I can imagine. There was some other glitch with it.
You can do it on, it maybe because I haven't updated it, I need to update it. So that might be the case.
It might be, but I don't necessarily think that's the case. You can go by, the IT people in the Pierce building in front, and they might be able to tell you why you can't, because they're supposed to be able to help you with that.
Okay.
Why would it not be the same? Putting everything in.
You know the question that we had, it was kind of random, it was the one with the two roads intersecting?
Mhm.
Okay. Will there be any questions like that on the test?
I think I Yeah, I think that's starting to ring a bell. I remember that one being challenging. There's a little video that goes with that. Watch the video. It'll help you figure it out.
Okay, got it.
Yeah.
But.
I remember that
Not
from
too
last
many on the
time.
test?
Hmm?
Maybe one or two?
Oh, no, I wouldn't put that on a test,
Oh,
no.
thank you. Okay, I will look at the video then.
Yeah, the video explains it very well. I'm just gonna go from scratch and put it back in this calculator since it was working right a minute ago and try to do a side by side and see what's going on.
On one of my shows, it mentioned that.
Okay. Ah. And I didn't catch it when I looked at it a minute ago. So let me look at the others. That's right. Did these two match what yeah, these matched what I got.
No, that's what you wrote down. They didn't match that.
Okay.
I couldn't get it to.
Okay, on yours,
Mhm.
you got a 28 instead of 23
Oh.
in matrix B. Let me fix that. And it would be easy to type it wrong, and I didn't even catch it the first time I looked at it.
Yeah.
Okay. Okay, that one's right. Okay, they should work now, so let's see. Okay, that one's working. Yeah, yeah.
Okay. So it was just the first.
It was just the first one.
Okay. All right. I gotta touch that.
Look really carefully.
Yeah.
That's one of the reasons too, although I don't know that it would have helped you this time, that I always say to write out all your work, because that way if I see that you copied something wrong, I know you knew what you were doing, but you entered something wrong.
Yeah. In that case, I wrote it down and then I just followed what I
Yeah,
wrote.
and I'm bad to do the same thing.
Yeah.
Once I've written it on my paper, it's right, I don't care. It must be right.
Are you thinking you know what it is?